So this lesson is applying coordinate geometry. Also, I like to call this unit abstract coordinate geometry because we're going to be working with the coordinate plane with parallelograms and other polygons to figure out coordinates of vertices. So to name coordinates of special figures by using their properties is our objective. So the first example here is I have three vertices of a parallelogram and I want to find where can D be to make a parallelogram. So the reason why I have the same thing 3 times is because if you have 3 vertices and you want to make a parallelogram, there are 3 possible points for point D in order to complete the parallelogram. So let's zoom in. So first thing you have to know is your properties of a parallelogram. Well, properties of a parallelogram, I know that opposite sides are parallel. So if opposite sides are parallel, I know that AB and CD will be parallel in this case. So I know that AB has to be parallel to CD. Well, if I connect A to B and I find my slope is 1, 2, 3, so it's 3 over 1. Therefore, my CD slope also has to be 3 over 1. So to find D, it's up 1, 2, 3 over 1. And there we go, there's point D. So if I connect my point D, D is over 8 and up 6. And there is my parallelogram. Well, that's not the only location for D. I can also have, again, AB parallel to CD. But in this case, I know my slope is 3 to 1. Because my slope is 3 over 1 for AB, therefore it's 3 over 1 here. So instead of going up 3 over 1, I'm going to go down 3 over 1. So 1, 2, 3 over 1. And here is point D. So if you can use slope in your properties of a parallelogram to find the location of your fourth point to complete the parallelogram. There we go. So there's point D. Point D is 6, 0. And again, I'm just using the concept of slope, opposite sides are parallel in a parallelogram, to find the location of point D. So there's another point for point D. So in this case, I am going to do AC slope. So I know that AC has to be parallel to BD. So my slope of A to C is up 1 over 1, 2, 3, 4, 5, 6. So therefore my BD slope is 1, 6. Well, if I go up 1 over 6, 1, 2, 3, 4, 5, 6, this is the same. So instead of going up 1 over 6, I reverse it. I go down 1 to the left 6. So if I go down 1, that's negative. Okay, down 1 over to the left is negative 6. So negative, negative turns to a positive. So I go down 1 from B over to the left 6. 1, 2, 3, 4, 5, 6. And there is point D. So now I know right here are my 3 locations for D, in this case negative 4, 4, to complete a parallelogram. So let's zoom out. So in the first example, I used AB. Second example, I used AB again. And then third example, I did AC. So those are the 3 locations for point D in order to complete the parallelogram. Now let's start doing abstract coordinate geometry. So what are the coordinates of the vertices of each figure? So in other words, I want to know what is the coordinates for S, Q, R, and E in the square. Well, I know that S to Q is 2A, so S to Q is 2A. Therefore, everything else is 2A. Because a square has all congruent sides and all angles are also congruent. A square is also a rhombus and a rectangle and a parallelogram. So all side lengths are 2A. Okay, the axes bisect each side. So the y-axis bisects each side, and the x-axis bisects each side. So that means they're all these little congruent parts. So what does that mean? Well, if S to Q is 2a, half of it is a. So all these are a in length, distance. Now we have to apply the direction because we're in the coordinate plane. So this a over here is negative by the S. Why? Because we're to the left of the y-axis. The a is negative because we're below the x-axis. The a by the e is negative because, again, anything to the left, the y-axis is negative. Anything below is negative, so this is negative. Anything below the x-axis is negative. Anything to the left is negative. So now I can find my coordinates. So the coordinates of Q, I go over A, up A. Coordinates of R, I went over A, down A, so it's over A, negative A. To E, I start at the origin, so I go over negative A, down negative A. So E is negative A, negative A. And to get the S, I start at origin, and I go over negative A, up A. So S is at negative A, comma A. So those are my coordinates. So let's find the coordinates of the isosceles triangle. Well, if it's isosceles triangle, I know that the legs are congruent. Okay, I know a median is a bisector. From T to I is 2a. So if the y-axis is a bisector, I know T to O and O to I are congruent. So if the whole thing is T2a from T to I know this is A and this is A. But since this T to O is in the negative direction, I know that's negative A. So I can apply my coordinate geometry rules that the I location is over A, up 0. The T is negative A, comma 0. Now the R location, I went up, I don't know how much I went up, but I know I went 0 left and right, and it's up Y. So I introduced a new variable. R has no relation to Ti in this case. I don't know if it's up 50, up 100. I'm just going to say it's up Y spots. So I want to know the coordinates of RECT in this rectangle. So in this case, I know that the length is 2b, so the distance from E to C is 2b. Therefore, R to T is 2b because it's a rectangle. Opposite sides in a rectangle are congruent. And the height is A. So if C to T is A, therefore R to E is also A. Also, the y-axis is a bisector of ECRT, so I know that I have congruent segments around the y-axis. So this is B, 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 and B. But I have negative B because the direction is to the left of the y-axis, and I have negative B because the direction is left to the y-axis. So now I could find my coordinates. So to C, I went over B, up A. To get T, I went over B, up 0. R is negative B, comma 0, and E is over negative B, up A. So the kite, let's find the coordinates of the kite. So I know that K to O is B. I know O to T is C. I know this B has to be negative because it's to the left of the y-axis. The x-axis bisects IE, so if IE is being bisected by the x-axis, I know that I have OI is congruent to OE. But if IE is 2A, so if I to E is 2A, but it's being bisected, so half of 2A is A and A. O to E is negative A. Why? Because anything below vertical, the x-axis is negative direction, so it's negative A. So now I can get my coordinates. T is over C, comma 0. K is negative B, comma 0. To get I, it's left and right 0. I didn't move anywhere on my x-axis, but I went up A. And E, I didn't go left or right on the x-axis, so it's 0, comma, negative A. Here's a good example for midpoint formula. So I have a general parallelogram with vertex at the origin, one side along the x-axis. What are the coordinates of D, the point of intersection of the diagonals? Well, I can find coordinate D by doing the midpoint of C to A. Because if I use the midpoint formula and my diagonals have the same midpoint, it proves that the diagonals bisect each other. So I need to show CA midpoint is equal to BO midpoint to show ABCO is a parallelogram. So remember, our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So this is our midpoint formula. Well, let's do the CA midpoint. I have to show that it's the same as the BO midpoint. The reason why I'm doing that is so I can show that this is indeed a parallelogram. If the midpoints are the same of a parallelogram, it shows that the diagonals bisect each other. So the CA midpoint is add up my x values. So my x values of C to A is 2A plus 2B over 2, and add up my y values, so that's 2C plus 0 over 2. 2A plus 2B over 2 simplifies to A plus B. 2C plus 0 over 2 simplifies to just C. So there is my midpoint of CA. Now I need my BO midpoint. So my BO midpoint, I take my coordinates of B, okay, the x value, which is 2A plus 2B. The origin is 0, 0, so I have to add in 0 over 2. Add in my y coordinates, 2c plus 0 over 2, which simplifies to 2a plus 2b over 2, comma, 2c over 2, which reduces to a plus b, comma, c. And notice that they are the same. So D is the bisector of both BO and AC. Last example, I have a parallelogram, KLMO. O is at the origin, so O is at 0, 0. I know from O to M is 2A, so M is 2A, comma, 0. Therefore, I know from K to L, I know that this is also 2A from K to L. How do I know that? Well, opposite sides in a parallelogram are congruent. Now I need to find the coordinates of K. Well, I know I need to find this black segment. I need to find this. Well, how do I find it? I have to use my x coordinate of L. This is the x coordinate of point L. This tells me the distance away from the y-axis. So I know from here to here is 2a plus 2b. Well, let's use segment addition. If I know that this part from K to L, okay, is 2a, what's missing to make it equal to 2a plus 2b? Well, the answer is pretty easy. It should be apparent that if I have 2a and 2a, what's missing? Well, what's missing is 2b. So this is 2b. Because that's what was missing. So that's segment addition. If I had 2a plus 2b, I know one part of the segment was 2a. Well, what's missing to make it congruent to 2a plus 2b? Well, 2b. Now I can find the k value, which is over 2b, comma, c. I don't know it's c because the c values I got from the L, since L and K are on the same line, they have the same y value. So K is at 2b, comma, c. So K is 2b, comma, c. So that concludes the lesson for abstract coordinate geometry. If you have any questions, shoot me an email. Please do the practice problems in Math Excel.